I am Professor Antonio S. Marahas, and this is Digital Technique Fundamental. Binary number system. So, binary number is defined as, again, a number system with two separate symbols. Represented by zero and one only. Okay? It has a radix or a base of 2. Okay? So, again, it is a number system with two separate symbols represented by 0 and 1 only. So, walay 2, walay 3, and so on. Only 0 and 1. Okay? It has a radix or a base of 2. Example. Say 1, 0, 1, 1, 0, 1 of base 2. Again, this one here is called the radix or the base. Okay? So again, the radix or the base identifies the type of number system that we are using. So in this case, you have a binary number. Bi means 2, di ba? So, how do we obtain the positional notation of this particular binary number? So you have the number 1 here multiplied by the base 2 raised to what? 1, 2, 3, 4, 5. So raised to the 5 plus 0 times 2 raised to the 4 plus this one here 1 times 2 to the 3 plus this one 1 times 2 to the second plus this one 0 times 2 to the first plus this one here 1 times 2 to 0. Okay? So actually, this one here can be eliminated because any number multiplied by 0 is simply 0. So if we will obtain the value of this number, again, this is the positional notation equivalent. So you have 2 to the 5 is, I believe, what is 2 to the 5? 2, 4, 8, 16, 32. Okay. So 32 times 1 is 32. Plus, you have what? 2 to the 3 is 8. Right? 2 to the 3 is 8 times 1 is 8 plus 4 times 1 is 4 plus 1 times 1 is 1. Okay? So you have 32 plus 8 is 40 plus 4 is 44 plus 1 is 45. So this is 45 of base 10. Okay, so this is not base 2, but base 10. In other words, any number system, once positional notation is obtained, becomes base 10. Ano man? Because base 10 in positional notation is used as the number which is your reference number system. Okay, that is why 45 of base 10 here is equivalent to 101101 of base 2. Okay? So they are equal. this one here is equal to this one. But this one here is in base 2 and this one here is in base 10. So, just to tell you in advance that any number system, once positional notation is obtained, it becomes a base 10. Okay, so more or less, mura siya og conversion from any number system to base 10. Because base 10, as I've said, is your reference number system in obtaining positional or using positional notation. Okay, so another example. Let's say you have 101110.101 of base 2. Okay? So, how do we obtain the positional notation again? Again, without the presence of your 2 here, this number can be a decimal number, this can be an octal number, and this can also be a hexadecimal number system. That is why, with the presence of your base, we can say that this is a binary number system. Okay? So, positional notation, you have 1 times 2 to what? 1, 2, 3, 4, 5. Okay? That is after, what do you call this one, by the way? This is what we call the binary point. Not decimal, but a binary point because this is a binary number system. Katong kaganiha, decimal number system, katong point dito, that is a decimal point. Kani, we're using binary number system, so the point here is actually called the binary point. So you have 1 times 2 to the 5 plus 0 here, not included. So you have this one. 1 times 2 to what? 1, 2, 3. Plus 1 times 2 to the second. Plus 1 times 2 to the first. This one here, 0 not included. Plus 1 times 2 to the minus 1. Okay? That is, after a binary point, you have minus 1, minus 2, minus 3. Okay? Then you have what? 1 times 2, this one here, to what? Minus 3. Okay? Can you follow? So, this will be what? 2 to the 5 again is 32 times 1 is 32. Plus 2 to the 3 is 8 times 1 is 8 plus 2 to the 2 is 4 times 1 is 4 plus 2 to the 1 is 2 times 1 is 2 plus 1 half 1 over 2, correct? Plus 1 over 2 to the 3. Okay? Because the sign here becomes positive once it is converted into division. Okay, so you have what? 40, 44, 46. Okay, 46 point what? 1 half is 0.5. This is 0.5 plus what is 1 over 8? What is 1 over 8? That is equivalent to 0.125. So the total will be 46.625 of base 10. Okay, again, it's now in base 10. Okay, so you have 101 is equivalent to 0.625 of base 10. So in other words, this value here, 101110.101 of base 2 is equivalent to 46.625 of base 10. Okay? Again, this one here is called the binary point, and this one here is called decimal point. So, take note of that. Kaya basing gawas na sa itong mga quizzes or sa quiz na to. The first quiz na to, basing gawas na siya, no? So, take note of that particular discussion on the binary and decimal point. Okay? So, that's what is binary number system.